Hello everyone. The topic that we'll be discussing is on the important property of electrostatic field. So far in the previous lecture we have calculated the electric field line or the electric field strength at a point due to a point charge, then the electric field due to infinite plane sheet, and then the electric field due to a charge distribution in an infinite long straight wire. Then we also discussed about electric field intensity due to an electric dipole. So the question may arise, what is the important or what is the property of this electrostatic field? One of the property of the electrostatic field is the line integral of electric field from a point A to a point B, we can say, is depend only upon the endpoint A and B, but not on the path AB. The line integral of electric field from a point A to a point B depends upon the endpoint A and B, but not on the path AB. This is due to the conservative nature of electric field. So now let us consider a charge, say Q, located at the origin O. So you can mark this one as X, this one as Y, this one as Z. So somewhere here there is a point A and there is a point B. The position vector of the point A will mark by RA, and the position vector of a point B we will mark by RB vector. Now let us draw a path AB, say like this. Then let us divide this path AB into an interval. So for simplicity, so let us consider this path AB to be divided into three intervals. We can say that this one is a point C and this one is a point D. But remember that this point C and the point D, if we divide this part AB into a very large interval, this C and D, they are almost coincide. So let the position vector of C is R and the position vector of D is R dash. So from here to here, it is delta L. Remember that we have divided this part AB into a very large interval, but for simplicity, I will mark here only three intervals. So from A to C, C to D, and from D to B. Now, this one, the vector from C to D is delta L. If you apply a triangle law of vector addition in a triangle OCD, we will get R dash equal to R plus delta L. Or from here, we can write that delta L is R dash minus R. Remember that this mod of delta L is very, very small and it is tending to 0. The magnitude of that delta L vector is very, very small, it is tending to 0. Then, if mod of delta L is tending to 0, it means that R dash is approximately equal to R. In that case, if we add R plus or R dash plus R, so this is approximately equal to 2R. But one should be noted that R dash minus R is not equal to 0. Remember that. We are going to apply, or we are going to use this equation in our discussion. So now, let us find the dot product of E dot delta L. So the dot product of E dot delta L, that means we take the dot product of electric field multiplied by this delta L vector, which means it is from C to D. So this can be written as, so what is the electric field? The electric field is equal to 1 by 4 pi epsilon naught. The charge here is Q and the distance is this, so it is R squared. So the electric field is a vector quantity, so then we take R cap. That means the direction of the electric field is readily outward. It is along this vector R. So dot delta L. If we have any vector A, say A, this can be expressed as A cap, where A cap is a unit vector, or we can write mod of A cap. So therefore, from here, from this equation, we can write Q divided by, so what is R cap? R cap, if we use this equation, so A cap here is A vector divided by mod A. So similarly here, so what is R cap? It is R vector divided by R, so R into R square become R cube. So this is the dot product R dot delta L. Now, what is R? What is R dash? As R dash is nothing but R plus delta L. R plus delta L. So I want the dot product R dot delta L. So let us take the dot product between R dash and R dash vector. So R dash dot R dash vector itself. So we will get R plus delta L dot R plus delta L. So this can be written as, so what is R dash vector dot R dash vector? This is equal to R dash mod of R dash whole square. So this is equal to, take the dot product, R dot R, so mod of R square. R dot delta L become R dot delta L. Next, delta L dot R. So delta L dot R is the same thing as R dot delta L multiplied by 2. Delta L dot delta L become mod of delta L square. As I have mentioned earlier, that this delta L is a very small quantity. So since it is a very small quantity, if we square the small quantity, it will be much smaller. So therefore, this one is negligible. So this equation can be written as, R mod of R dash is simply R dash, so square, equal R mod of R, simply R, so R square, so plus twice of R dot delta L. So this can be written as R dot delta L is equal to what? 1 by 2 R dash square minus R square. I need this equation, so I will drop this part. Then from here, what is R dot delta L? R dot delta L is equal 1 by 2. Say I will mark this one as equation 1. R dash plus R, then R dash minus R. So this can be written as I have mentioned earlier, that R dash plus R can be written as 2R. So 1 by 2 2R. Then R dash minus R, it is not equal 0, so therefore it will remain as it is, like that. Then this 2 will get cancelled. So therefore, if we put this value in this equation, R dot delta L in equation 1. So equation 1 turned out to be E dot delta L is equal to how much? 1 by 4 pi epsilon naught then Q divided by R cube. So what is R dot delta L? It is R dash minus R. So this will get squared. So this can be written as Q by 4 pi epsilon naught. Then R dash minus R divided by R square. So from here, if I put here 1R, then I can put here R square. So therefore, instead of R square, I can write R dash minus R divided by R dash, like that. So this becomes Q by 4 pi epsilon naught. So R dash divided by R dash minus R divided by R dash. So R dash will get cancelled. So R will get cancelled. So it becomes Q by 4 pi epsilon naught, then 1 by R minus 1 by R dash. So this is the dot product of E dot delta L for this interval C to D. Now, if we add them all, like from A to C, then C to D, then from D to B, that is the total integration. It is from, if we add them, it means that we take the total integration from A to B. So from A to B, E R dot dl vector. Then this one is equivalent to Q by 4 pi epsilon naught. If we add them, some term will get cancelled in between. So this can be written as 1 by RE minus 1 by RB. So this equation shows that this equation shows that the line integral of electric field depends upon the endpoint A and B, but not on the path between A and B.